Okay, so yesterday we solved inequalities that were linear. Today we're going to solve higher order inequalities, which basically means inequalities that might be like quadratic or cubic. When they get too complicated, we're going to use a calculator. But for ones that are a little bit more basic, we'll use algebra. Okay, so we're going to start off with a formula that's used in physics, okay, that models projectile motion. Okay, projectile motion is basically the motion of an object if you throw it. You could throw it straight up. Or you could throw, like in baseball, somebody from the outfield throwing a baseball in. And what this equation gives us is the height of the object at a given time. And that depends on two different things. It depends on how fast you initially throw it, and it depends on how high you initially throw it from. Okay, so t is time, v sub 0 is your initial speed that you throw it at, and s sub 0 is your initial height. If the problem says an object is thrown from ground level, that means the initial height is 0. So if you see ground level, there's no initial height. Most of the time when you throw something, there is an initial height. It's how high the object is off the ground when you release it from your hand. Has anybody done projectile motion in physics? Not yet. When you do it in physics, you probably won't see the 16 there. You're going to see 9.8. The reason for that is we're doing everything in feet per second. A lot of times in physics, you use metric. So you'll do it in meters per second. Okay, so the 16 has to do with the acceleration due to gravity. Okay, so we'll use a graphing calculator for the first one. It says a ball is thrown straight up from ground level. It's thrown at an initial speed of 80 feet per second. There's all kinds of questions we can ask, but the first one I just want to know is, when is the ball at least 64 feet off the ground? Okay, when is the ball at least 64 feet off the ground? Okay, first thing I need to do is fill in my equation for projectile motion. So I get negative 16t squared plus v sub 0, that's my initial velocity. Brianna, what's my initial velocity in this problem? It's 80t. And Darren, what's my s sub 0, or what's my initial height? 0. Initial height is 0. So we don't need that. And I want to know when the height of this object is at least 64 feet above the ground. James, what inequality symbol would that be? At least 64. So if I said to you, you need to score at least a 64 on the test, that means you could score.
You can score more than that.
Yeah, more than that. So it's 64 or more, which is greater than or equal. So you want the height to be at least 64. Okay, so let's graph it. We'll graph the left side in y1. So negative 16. Remember, for your variable, you have to use x on the calculator. And the other side, 64. Okay, so my y values, I know I'm going to have a horizontal line up at 64. So if I do a standard window, that's not going to work. Let's set the y max up to like 110. If the ball goes higher or whatever we're throwing is above 110 feet, we're going to go off the screen. We're going to have to fix it. What would be a good minimum height?
0.
Yeah, 0. This object isn't going to go below ground. And now x, that's my time. Okay. What would be a good minimum time? Oh, Kobe?
0.
Yeah, 0. We're not going to have negative time. That would that wouldn't make sense. And maximum time, that's how basically long the object is in the air for. Let's just leave it at 10 and see what happens. Okay, so there's the path of our object. Where the parabola in blue is above the red horizontal line, that's when the object is above 64 feet. So we're going to go second calc, intersect. Okay, I'll do the one on the left. If someone else can do the one on the right, we're going to need that one as well. Okay, so starting at 1 second. 1 second after the ball leaves my hand, it's going to be at 64 feet, and it's going to stay up above that for a little while until it starts to come back down. Okay, at what point does the ball start to come back down and go below 64 feet again? 4 seconds. Very good. Okay, so between 1 and 4 seconds is when the ball is above 64 feet. Before that and after that, it's lower than 64 feet. Any questions on that? Okay, we're going to do that algebraically in a minute, but that's how you do it graphically. Okay, next problem I want to look at is how long does the ball stay in the air for? Okay, when we're talking about something being in the air, how does that relate to its height? If it's in the air, then its height is what compared to ground level? It's greater than 0. The book goes with greater than or equal. Technically, once the height equals 0, it's on the ground. But we'll follow with what the book does. Okay, so the equation for our object, same as the last problem. Negative 16t squared plus 80t. This time I don't want to know when it's above 64. I just want to know when it's in the air, which is when the height is greater than or equal to 0. Okay, what can we factor out of the left-hand side? What do negative 16t squared and 80t both have in common? Alex?
T.
Yep, t. And what else?
8.
Yep, you could do an 8. We can even go a little bigger than 8. Anybody see what, Darren?
16.
Yeah, we can factor out 16, a t. We can even factor the negative out as well. Let's factor all that out. So that would leave you with t, and 16 times 5 is 80. Okay, now we got to use a little bit of common sense. Okay, we have two factors here. We're going to multiply that times that, and we want to get an answer that's not negative. Okay, greater than or equal to 0. Okay, Colby, T stands for time. What kind of number is the time going to be?
Positive.
Time is always positive. What do you get when you do something that's always positive times a negative? Negative. So the first factor is always negative. It's negative 16 times some positive number. So I have a negative. What about the second factor? If I want this whole expression to come out greater than or equal to 0, I'd have to do a negative times a negative. So somehow I have to find values for t that would make this second factor come out negative. So that's basically what we're looking at. When would t minus 5 be negative? If t minus 5 isn't negative, let's say it was positive, that's a problem. You're going to have a positive times a negative. That will not be greater than or equal to 0. Okay, so let's look at that. When is t minus 5? A more precise way to say it would be it's not positive, because we're including 0. So we get t, add 5 to each side, t is less than or equal to 5. So that means the object will be in the air for 5 seconds. Technically 4.9 repeating. And then once it hits 5 seconds, it's back on the ground. So the object is in the air for less than or equal to 5 seconds. Okay, second part we've already done graphically. We're going to look at it algebraically. When is the ball 64 feet off the ground? So take your same equation. This time I want it to be greater than or equal to 64. This is a quadratic inequality. Okay, when you solve a quadratic equation, what number do we generally like to have on one side? 0. So let's do that. Let's swing the 64 to the other side. Plus 80t minus 64. Okay, and what do all three terms on the left have in common? Or they're all divisible by... Yep, they are all divisible by 8, even bigger. 16. Yep. So what I'm going to do is I'm going to divide everything by a negative 16. The reason I'm going to do a negative is because I'm going to end up factoring. And when we factor, we like the squared term to have a positive, not a negative. So those are going to cancel. We're going to get t squared. 80 divided by negative 16 is negative 5t. negative 64 divided by negative 16 is plus 4. And on the other side, we have 0. What do I have to be careful of here, though? Yep. Got to flip that inequality. If I don't flip it, it's wrong because I just divided by a negative. Okay, now we have to solve that, but it is factorable. T and t. We need minus, minus, and 4 and a 1. Okay, any questions on that? And now we have to look at the two roots that would make each factor 0. The first factor would be 0 when t equals 4. The second one would be 0 when t equals 1. And that's exactly what we got before. Between 1 and 4 is when the object is above 64 feet. Okay, so you might be wondering, how do you kind of get from that exactly to what we had, which was this? Well, I'm going to show you how to do this with what's called a sign chart, or sign pattern chart. Okay, so this, how you get from this step to this step is going to make a lot more sense in a minute. Okay, that's what I'm going to show you now. Okay, so the idea of a sign pattern is that every linear factor, okay, a linear factor is a factor that if you graph it, it's a straight line. So x plus 5, 2x minus 7. Okay, those are linear. Every linear factor is 0 for exactly one value of the variable. As an example, t minus 1 is a linear factor. There is exactly one value you can pick for t that would make t minus 1 equal to 0. In that case, it's 1. Okay, t plus 4, that's also a linear factor. There's exactly one value you can pick for t that would make t plus 4 equal to 0. In this case, it's negative 4. Okay, if we look at making a number line, okay, and I put the root on it. Okay, the root of this first factor is 1. If you take numbers smaller than 1, 0, negative 10, negative 20, and you plug them into t minus 1, what would be the sign of your answer? Positive or negative? Oh, Andy? Negative. If you plug in any number smaller than that root, you're going to get negatives for t. What if you plug numbers bigger than the root in, like 10, 20, numbers like that? Yeah? It'd be positive. So the root separates the number line into the numbers there, and you plug them in, you get negatives. And then the other set of numbers, you plug them in, and you get positives. Okay, so what we have to do is draw a number line just like I did for every factor in the problem. Generally, there'll be 2, sometimes 3. So we draw our number line, mark the roots, just like I did. Just put a vertical line right on the root. And then determine the sign of the numbers in each section, negative, positive. Okay, page 113 shows you a few more examples, but we're going to do one right now. So. Okay, once you have a number line drawn for each individual factor, then you can put them together and get the final answer. And I'll show you how that's going to work with this problem. Okay, this whole method assumes that you can factor the problem you're trying to solve. If you can't factor it, sign patterns don't work. I have to give you a problem that can factor. Okay, so this one will factor. 2x and x. What about my signs in parentheses? Oh, Cody?
Positive, negative.
Yep, positive, negative, and my suggestion would be to do it like that. And 2 numbers that multiply to give me 5. How about Kelsey? 5 and 1. And we should put the 5 here and the 1 there. Let's check it. 2x squared, 10x, take away 1x, that's 9x. Okay, so we factored it correctly. So now what we're going to do is make a number line for each factor. Okay, first thing I have to do is find the root. Okay, I need to find the value of x, that if I plug it into 2x minus 1, it would give me 0. What would that be if you solve it for x? Augustine?
0.5.
Yeah, 0.5 or 1/2. Okay, now we have to just ask 2 questions. If we plug numbers in smaller than 1/2 for x, I want to know, do I get negatives for my answer, or do I get positives? Okay, so let's pick a number smaller than 1/2 that's easy, 0. If I plug 0 into 2x minus 1, Casey, will that give me a negative or a positive? So let's try 0. What's 2 times 0? 0 minus 1? Negative. Okay. Now let's see what happens if we go to the other section of the number line. Right? If we plug in numbers bigger than 1/2. Okay, let's try 5. Anything bigger than 1/2 is fine. Okay, if we do, Darren, what's 2 times 5?
10.
Take away 1? And that's what kind of number? Positive. Okay, do the same thing now for the other factor. James, what's my root for x plus 5?
-5.
Yep, -5. Okay, Jill, if I pick numbers smaller than -5 and plug them into x plus 5, what kind of number do I get? Okay, let's try -10. Yeah, -10 plus 5 would be a negative. Okay, Victoria, if I pick numbers bigger than -5, like 0, and I plug that in, what kind of number do I get? Positive. Okay, now we're going to look at combining them together. So we're going to have a number line with 3 parts on it. Put -5, because that's one of your roots. Put 1/2, that's another root. And there's 3 regions we need to check. Less than -5, between -5 and 1/2, and more than 1/2. Okay, how about Alex? If I pick numbers smaller than -5 in the first factor, what kind of answer do I get? If I go smaller than -5.
Negative.
Yep, I get a negative. I'm just going to write that off to the side. So negative times a, let's do it in the second one. Cody, if I pick numbers smaller than -5 in the second factor, I get what kind of numbers?
Positive.
So smaller than -5 goes that way. Those are your negatives. Okay, what's a negative times a negative, Casey? Positive. So if you pick any number smaller than -5, plug it in, do the arithmetic out, your answer will always be a positive. Okay, let's check what happens if we do numbers between -5 and 1/2. Okay, Andy, in the first one, if I pick -5, it would be somewhere over here. If I pick numbers between -5 and 1/2, what do I get in the first factor?
A negative.
Yep. I'd get a negative times Kobe, in the second part, between -5 and 1/2, what kind of numbers do I get? Positive. So the result here, Brielle, if I do negative times positive? Negative. If you pick numbers in this interval, this inequality will come out negative. And let's check the last one, numbers bigger than 1/2. Okay, Augustine in the top one, numbers bigger than 1/2 come out
Positive.
positive. Times Emily, in the second one, numbers bigger than 1/2 come out positive. And a positive times a positive is a positive. So now we know exactly where this inequality is above 0 and below 0. And the question was, where is it above 0? Where is it above 0? Here and there. So now we have to write our answer as a interval. Okay, we can pick any number from -infinity up to, but not including -5. Why can't I include -5? Augustine?
Because it's a more than sign, but without a no equals.
Without the equal, yeah. They strictly want to know where it's more than 0, not equal to 0. If I put a bracket on -5, then it would equal 0 at that point. All right, so don't include -5. And then the next interval, we could pick any number from 1/2 to, what's my upper limit on this part? 1/2 to, Emily? Infinity, yeah, there's no upper limit. So that's the answer to the inequality. Pick numbers between -infinity and -5, or we could go up to 1/2 and positive infinity. Either interval. Any question on that? All right, let's try one more of those. So here's a cubic that's already been factored for you. Okay, let's start with the roots. Kobe, what number would I plug in to the first factor to make it 0?
So which one?
The first factor, x.
-3.
That's the second factor. So if you plug -3 into the second one, that's 0. What about the first one?
0.
Yeah, just 0. If you fill in 0 for the first factor, it makes it 0. If you fill in -3 for the second factor, it makes it 0. And Brianna, how about the third factor? 1. Now we just have to determine what happens on each part of the number line. Okay, Darren, if I plug in numbers less than 0 into the first factor, what do I get? I get negatives. If I plug in numbers more than 0 into the first factor, I get positives. Okay, James, if I plug in numbers less than -3 into the second factor, what kind of numbers? Negative. If I plug in numbers more than -3, if you're stuck, just try one. 5. 5 plus 3, that's a positive. Okay, and the last one. Jill, if I plug in numbers less than 1, what will be the sign of my answer? These will be negatives, yep. If I plug numbers in that are more than 1, my sign is positive. Generally, that's how it goes, unless I did something like that. Now that would have just switched the negative and the positive around. Okay, so you do have to be careful and check it. Okay, on my final number line, how many sections am I going to have? Kelsey? How many tick marks or divisions do we have to put in it?
3 tick marks.
3, so that divides it into
5.
4, yeah. 3 divisions will make it into 4 sections. So we have -3, 0, 1. Okay, let's check what happens when we're smaller than -3 in all these factors. Okay, Victoria, if I'm smaller than -3 in the first one, what kind of numbers? That's a negative. Times if I'm smaller than -3 in the second one, Alex?
Negative.
Negative. Okay, and Cody, if I'm smaller than -3 in the third one?
Negative.
Negative. So if you pick numbers smaller than -3, you're going to end up with a negative times a negative times a negative, which Casey is, that's a negative. Now generally the sections alternate, negative, positive, negative, positive. Let's just do one more section to make sure that works. Between -3 and 0. Andy, in the first factor, between -3 and 0, I am negative. Okay, Kobe, in the second factor, between -3 and 0,
Positive.
that's positive. And in the third factor, Brielle, between -3 and 0, we're in the negative part. Okay, Emily, what's a negative times a positive times a negative? Okay, there's my positive. You could check the other intervals, but that's what's going to happen. They alternate. So in this case, we want to know where is my inequality greater than or equal to 0. There and there. Okay, so that would be from -3. This time I can include it because it's equal to. So pick numbers between -3 and to 0. Union. From 1 to positive infinity. That's the answer to the inequality. Okay, again, this only works if you can factor. If you can't factor, you can't do this. Any questions on that one? Okay. I'm not going to go through the last one, but division works exactly the same. Negative divided by a negative would be a positive. Negative divided by positive is negative. Positive over positive is positive. You just find the roots, and you do exactly the same thing. No difference. Any question on how you do this one? Okay, if you want to know what the roots are, they would be 4, and this one would be -5/2. And then you'd check negative, positive on each side. The only thing you'd want to be careful of here is make sure you're never dividing by 0. So if you have an interval that would cause you to divide by 0, which you shouldn't, Well, you could. You'd have to be careful of that. Okay, so even though this has an equal to, do not include that actual number in any interval. If you do, you're going to cause division by 0. So there should be no bracket, no matter what, next to negative 5 halves, if that's part of your answer in any way. Yep. The part? Yeah, I can do it quick. So it'd be negative, positive. On this one, if we do, that would be negative. That would be positive. And the final answer, okay, in the section less than negative 5 halves, that's negative times negative, or I'm sorry, negative divided by negative. It's positive. Between negative 5 halves and 4, that's a negative divided by a positive. That would be negative. Bigger than 4, positive divided by positive. So now the answer is, where am I less than or equal to 0? In that interval, but I can't use a bracket on negative 5 halves. That would cause division by 0. So pick any number from negative 5 halves, not including it because of division by 0, up to and including 4. 4 is okay to include. And if negative 5 halves didn't cause division by 0, I would have included that as well. Okay, if you can't factor it, use the graphing calculator. Okay, so what we'll do, we'll solve this one, but I want to get everything on the left. That way I only need to graph one thing instead of y1 and y2. So it's going to be minus 7x plus 6. So I'll graph that and then see where is it greater than or equal to 0. All right, so we've got x cubed minus 2x squared minus 7x plus 6. And we should go back to a standard window. Okay, I'm looking for where this graph is above 0. So you know what, let's do it like this to save a little time. Okay, first thing you'd have to do is calculate that intersection point, which I'll call A, this one, which I'll call B, and that one, which I'll call C. Okay, you'd need to find what A, B, and C are. And where am I above 0? Well, in that section between A and B, and from C on, I'm above 0. Okay, so the answer, just using A, B, and C for the roots, between A and B, just find out what those are. Union from C to infinity. Any question on how you'd actually find the roots A, B, and C? You'd have to do each one at a time. So I might do this a couple times today just to save a little bit of time. If you wanted to know where you're below 0, well, that'd be from negative infinity up to A, between B and C, and that's it. Okay, so once you have A, B, and C, you can do above or below 0. Any questions on that one? All right, so that wraps up 2.5. So 3.1. We're going to look at graphing polynomials. Okay, that's generally what a polynomial looks like. You start out with an x that has the highest exponent. Then you write the next highest exponent. Finally, you get all the way down to just having an exponent of 1. And then your constant goes last. Each one of these x terms could have a coefficient. which I'm just calling a sub n minus 1, and so on. You have to make sure that n is a non-negative integer. You cannot have negative exponents when you have a polynomial. N has to be a non-negative integer. The coefficient in front of x, well, can be that. Okay, so what this says is, for all, that's what that symbol means, for all values of n, the coefficient is a real number. Just so I don't have to write that out. So for every value of n, the coefficient, the thing in front of x, is always a real number. So what I'm saying is you can't have an imaginary number in a polynomial. That's not a polynomial. Coefficients have to be real. And if your first coefficient isn't 0, okay, then that exponent, the highest exponent, is what we call the degree of the polynomial. Okay? Usually we write polynomials in descending order. Highest exponent down to lowest. Like 3x squared plus 2x minus 7. Started with the highest exponent, down to the lowest. And again, that highest exponent, as long as that term doesn't have a coefficient of 0, it's called the degree. So if I did this, what would be the degree of that polynomial? 0x to the 5th plus 2x squared. Augustine? 2. This first term isn't even here. It's 0 times something, which is just 0. So the highest exponent that really matters here is 2 on the x. Okay, and we have special names for some polynomials. If it's a degree 1, it's linear. How about if it's a degree 2? Anybody know what we call a degree 2 polynomial? Think about the kind of equations you solve that have squareds in them and the formula that solves those kinds of equations. Yep.
Quadratic.
Yep, quadratic. And if you have a degree 3, that's cubic. Sometimes we refer to a degree 4 as quartic. Beyond that, there's no special name. We just say we have a degree 7 or a degree 10 polynomial. Okay, but those names are used a lot. Okay, what's nice about polynomials is all you're doing with a polynomial is taking a value, raising it to a power, that's an integer power, non-negative integer power, and multiplying it by a number. You can do that to any x value that you want. There's no restriction on the domain of a polynomial. Any number you can think of that's real can be raised to a non-negative integer and then multiplied by a number. Anything. Okay. But the range depends. Okay, the range depends. So we'll look at that a little bit. Okay, any question why the domain of a polynomial is all reals? Just think of any kind of polynomial you want. There's no restriction on what I can let x be there. I can square any number I want and triple it. I can take any number I want, multiply by 4, add it all up. I'll never get a divide by 0, and I'll never get something that's square root of a negative. Polynomials can't have square roots in them. Not for exponents or things like that. They have to be non-negative integers. Okay, so a cubic function has that form. It's generally what cubic functions look like. In fact, this is pretty much what odd degree polynomials look like in general. One end goes up forever, one end goes down forever, and there's some turns in the middle. How many turns are there? One less than the highest exponent. Okay, a fourth degree polynomial is going to be more like a parabola. Okay, a fourth degree polynomial either has a minimum value and both ends go up forever, or it has a maximum value and both ends go down forever. Just like a parabola. So all even degree polynomials look something like this. And in the middle, you can have a bunch of twists and turns, but both ends either go up forever or an even degree polynomial, both ends go down forever. And there could be a bunch of twists and turns in the middle. Kind of like this. Okay, any question on the general behavior of an even degree polynomial, in this case a fourth specifically, or an odd degree polynomial? If I were to draw the same picture, odds would look something like this. One end goes up, one end goes down, bunch of turns in the middle. Or you could have it this way as well. The other end is going down, the other end is going up, some twists and turns in the middle. Okay, so let's find the domain and range of that. Okay, if I ask you what the domain is of a polynomial, that should be an automatic, really not even thinking about it. The domain of all polynomials is the same. And what did I say it was earlier? Well, Emily? What's the domain of any polynomial? All real numbers. And the range, well, that depends. Okay, Brianna, is this an odd degree polynomial or even? It's even. Evens don't go up and down forever. Okay? This is going to be more like a parabola shape. Both ends are either going to go up or both ends are going to go down. In this case, because the coefficient in front of x to the fourth is a positive, it's going to look something like this. It may take some turns. It might do something like this. But both ends are going to go up forever. Okay, so let's graph it. Let's see what we got. So we have x to the fourth plus 5x cubed plus 2x squared minus 8x plus 1. And standard window, I think, is okay. Well, not quite. We got to set the y max or y min a little bit lower. So put your y min on negative 20. Okay, there's my fourth degree shape. Both the left and the right ends are going to go up forever. And in this case, there's a minimum, but there's no maximum. It goes up forever. Okay, to find the minimum, go second calc minimum. Okay, you pick a point to the left of your min, pick a point somewhere to the right, and do a guess. So my range of this function is as low as negative 11.95. It'll never get any lower than that. That is the absolute minimum for this function. And it goes from there up to positive infinity. I can put a bracket because I do reach negative 11.95 if we're rounding it. No upper limit. Question on that one? Just remember, your range is just how low it goes and how high it goes. So it will never stop going up. And it will never turn again because this is a quartic polynomial, so it can turn 3 times. And I can see all 3 turns on the screen. 1, 2, 3. So it's not going to turn and come back down later on. That's not possible. Okay, 5th degree polynomials, you can look at those. They're on page 143. The idea is a 5th degree polynomial, it can turn 4 times. 1, 2, 3, 4, and that's it. So here's 1, 2, 3, 4 turns. But fitting in with an odd degree polynomial, one end goes up forever, one end goes down forever, with some turns in the middle. Okay, all these turns that I just circled in the middle, they're what we call local maxes or local mins. Okay, we're not saying that a local maximum is higher than everything else on the graph. We're just saying that it's higher than everything around it. Okay, that's a local max. It's a point that's higher than all other points around it. From our graph, we can certainly see that the right-hand side, there's no stop to it. It goes to infinity. Okay, but we do have a local max. And there's a local min. Okay, a local min is a point on a graph that is lower than all other points around it. And that differs from what we call a global max or min. If we have a parabola, that point right there, there's 2 words, we could call it a global or an absolute minimum. Global min means it is the lowest point. There is no other point in the function anywhere that gets any lower than it. Okay. Versus a local min just means within a small area, it's the lowest value. But there might be other points, like down here, that do go lower than it. So, a question on the difference between a local max, local min, versus a global max or a global min. Okay, odd degree polynomials don't have global max and mins. One side goes up forever, one side goes down forever. There is no highest point in an odd degree polynomial. In an even, there is. Think of your parabolas. Okay? There is a highest or a lowest point.
What's a global?
Global is it's higher or lower than anything in the entire function. So if you think of a parabola, right there is a global min. There's no other point that ever gets lower than that. Parabolas don't have local min and max. To have local min and max, you've got to have some turning taking place in the function. Okay? This would be a local, min. This would be a local max. This would be a local min. And this would be a local max. Higher or lower than other things around it. But certainly, this local min isn't the lowest it ever goes. And together, your local max and local min are called local extrema. Okay, so let's graph x cubed minus 4x. And we'll find a couple things. We'll find the local minimum. Then we'll find the local maximum. Okay, we have to be careful when they ask us to find the minimum versus where it occurs. That's 2 different questions. Okay, let me graph it and show you. Say x cubed minus 4x. Okay, the local minimum is on the right-hand side. Go to the left, right. Okay, so the local minimum is negative 3.08. That's the lowest that the function gets on the y-axis. min is, what does it say, negative 3.08. Where does it occur? That's the x value. It's the x value that causes that y value. And it occurs at 1.15. So the actual local minimum is negative 3.08, and it occurs when x is 1.15. So that answers both questions. The second one, they're just asking me for the local maximum, not where it occurs. Okay, so for example, 3, I just need a y value. So we calculate maximum. Go left, right. The maximum is 3.08. So there's some symmetry to this graph. Okay. A little bit. Well, max is 3.08. If they asked me where it occurred, I'd say it occurs when x is negative 1.15. They didn't ask that, though. All right, so what we could use local min or even a global min or max for is finding a maximum height when we throw an object. Okay, so this goes back to the formula from physics that I gave you. And it says a baseball is thrown from the top of a building 200 feet tall. And they want to know basically what is the maximum height and at what time does it reach it. So our height is negative 16t squared plus my initial velocity times the time, plus I have an initial height of 200. Now the way you would do this algebraically, you'd set it equal to 0 and then complete the square. If you complete the square, which that's what we did when we studied quadratic transformations. Let me show you what you would get. Height equals negative 16 times t minus 2 squared plus 264. Okay, I'm not going to go through the entire completing the square to get that. Okay, but the important thing that it tells us are these two numbers right here. It tells us how far left and right we've moved the original, and how far up and down. If you don't transform your parabola, your vertex is at the origin. But we've moved our vertex 2 units to the right, and up 264 units. Completing the square would show us that. Okay, so I'll just write what you would do. So what that means is our vertex, that's the highest point, that's our maximum. Right? This is the height that the ball would reach. This is the time it would reach it. So once you complete the square, you have that right away. Number after the minus sign is the time, plus 264 is the vertical shift up. Okay, if you don't do it algebraically, we could do it graphically. You just type in negative 16x squared plus 64x plus 200. Okay, I know it's going to go as high as 264. I only know that because I already solved it a different way. But let's just set our y max at 280. I don't care about anything else. I'm just trying to see the maximum value. Okay, so let me calculate the max. So second calc, maximum. Notice here, if you set your x min to 0, the object is starting at a y-intercept of 200. It's because you're on top of a building when you throw it. And it's going to go up off the building and then go all the way down to the ground. Okay, so your maximum occurs at 2 seconds at a height of 264. Okay, so algebraically, complete the square to find it. Graphically, that's how you can do it. All right, and last thing we're going to talk about is increasing and decreasing. Okay, it's pretty easy to figure out where a function is going up and where it's going down. Okay, so we'll look at an example and then we'll define it a little bit more formally. Okay, where is this function increasing? From what point to what point? James?
B to C.
Yep, B to C. It's increasing. So we could say over the interval B to C. We're not going to use brackets because when it's exactly at B or C, it's not increasing, it's not decreasing. So between B and C, it increases. Where does it decrease? Can you give me one interval, Alex, where it's decreasing?
C to D.
Sure, C to D. And the other interval would be A to B. What happens when a function goes from increasing to decreasing? So point C. What would we call point C? Yeah.
Like, it's where it changes.
And we have a name for that point that we learned today. What would you call point C?
Local max.
It's a local max. So anytime a function goes from increasing to decreasing, you get a local max. Likewise, anytime a function goes from decreasing to increasing, you get a local min. And to find local max and min, we're using the calculator. Okay, but in calculus, you'll look at it in terms of the slope at that point. Okay, when you're decreasing, that's a negative slope, going down, going down, going down. And then all of a sudden you level out, right where it changes. Okay, when you level out, the slope at that point and that point is 0. It's horizontal, it's perfectly flat. So using the fact that the slope is 0, we could find the local max and min using calculus. Okay, but we're going to use the graphing calculator. So basically the formal way to say when a function is increasing, if x goes up, y goes up. If the values of f of x increase as x increases, then we say it's increasing. And increasing looks like that line. And then decreasing basically as x goes up, y goes down. Okay, or formally the way the book says it, a function is decreasing if the values of y, or f of x, decrease as x increases. Okay, so as x is increasing, y is dropping. Any question on that? So I would just summarize that in your notes as increasing. As x goes up, y goes up. Decreasing. As x goes up, y goes down. That's a quick way to summarize that. Okay, so our last one, we'll look at a function, and we'll find the intervals over which it's increasing and decreasing. This will be the last one. Okay, to save time, I think what I'll do is I'll just label the points and I'll leave actually finding them for you. Okay, so I think we had this earlier already graphed. X cubed minus 4x. Get rid of it. Go back to a standard window. And let's just take that. Here's our graph. So it asks us, where is this increasing? Where is it decreasing? Okay, that's A. Let's call that B. Does anybody remember what, I think we did calculate these, what the x was at 1.15? Are those the x values we had for this graph? It was 1.15? Okay. So then it's increasing from negative infinity up to, but not including 1.15. And then, sorry, negative 1.15. So that covers from negative infinity all the way up to there. And where else is it increasing? From what to what? James? Yeah, b to infinity, and I think b was also 1.15. And that covers from there to there. If it asked me where is it decreasing, I'd say from negative 1.15 to positive 1.15. That's where it decreases. Okay, it's a lot of stuff with the graphing calculator today, and the homework, I'd say more than 50% of it you need a calculator for, especially to find local max and local min. Okay, so on 116, that has to do with the sign charts. You won't need the calculator for the sign patterns as much. But it's 1, 3, 4, 16, 17, 20 to 22, and 27, 28, 30, and 49 to 51. Okay, 149, this is all graphing polynomials. It's 1 to 3, 9 to 11, 16 to 20, just evens on 16 to 20. And then 25, 29, and 38 to 40.